JavaScript. It's more than just a language, it's the very lifeblood of the modern web. Think of it as the universal translator, the lingua franca that allows every browser, every device to understand and execute instructions, bringing interactivity and dynamism to your fingertips. It's the engine powering dynamic content, the element that transforms static pages into engaging experiences. From simple animations to complex data visualizations, JavaScript breathes life into the web, and it's the backbone of complex user interfaces everywhere. Modern web applications with their intricate designs and seamless interactions rely heavily on JavaScript to deliver a rich and responsive user experience. It's the invisible hand guiding the flow of information and interaction. Its universal reach, built into every modern browser, makes it accessible to virtually anyone with an internet connection. This ubiquity is a key reason why JavaScript has become so indispensable. This widespread adoption makes it absolutely essential for web development. If you're serious about building for the web, mastering JavaScript is not optional, it's a fundamental requirement. Alongside HTML and CSS, the foundational building blocks of the web, JavaScript brings web pages to life, adding interactivity, responsiveness, and dynamic behavior that elevates the user experience. It's the tool enabling everything from simple animations like subtle hover effects and page transitions, to full-scale applications, complex single-page applications, and even server-side environments. Its versatility is truly remarkable. As you move beyond basics and delve deeper into the world of JavaScript, you'll encounter powerful features that let you build robust, scalable, and sophisticated, maintainable apps. These features are the key to creating professional-grade web experiences. This guide explores closures, those fascinating and sometimes perplexing constructs that allow you to encapsulate data and behavior, promises the elegant solution to handling asynchronous operations and avoiding callback hell, async, await, the syntactic sugar that makes asynchronous code easier to read and write, object-oriented patterns, the design principles that help you structure your code in a modular and reusable way, and common pitfalls, the mistakes that even experienced developers sometimes make, and how to avoid them. All with the aim of helping you think like JavaScript, to understand its nuances and leverage its power effectively. The goal is not just to learn new syntax, to memorize commands and functions, but a deeper understanding of how JavaScript works under the hood, how it interprets your code, and how you can use that knowledge to write better, more efficient, and more maintainable applications. Closures are functions that remember the environment where they were created. This means a function can access variables from its outer scope, even after that scope has finished executing. For example, a makeCounter function can create independent counters, each with its own private count variable, function makeCounter. LetCount = 0, return function, count++, console, log, count. Closures are essential for creating private state, organizing code, and ensuring event handlers remember the right variables, making your programs more modular and robust. JavaScript, as you know, operates on a single thread. This means that it can only execute one operation at a time. While this simplifies the programming model in some ways, it presents a challenge when dealing with tasks that might take a significant amount of time to complete, such as fetching data from a server or performing complex calculations. To prevent these long-running tasks from blocking the main thread and freezing the user interface, JavaScript relies heavily on asynchronous programming. Asynchronous operations allow the program to initiate a task and then continue executing other code without waiting for the task to finish. This is crucial for maintaining a responsive user experience, especially in web applications where users expect immediate feedback and smooth interactions. Promises offer a cleaner and more structured way to handle asynchronous operations compared to traditional callback functions. They provide a more readable and maintainable syntax, making it easier to reason about the flow of asynchronous code. Promises also help to avoid the infamous callback hell, where nested callbacks can lead to complex and difficult to debug code. At its core, a promise represents a value that may not be available immediately, but will be resolved at some point in the future. Think of it as a placeholder for the result of an asynchronous operation. This allows you to write code that anticipates the eventual availability of the value without blocking the execution of other code. When a promise is first created, it is in a pending state. This means that the asynchronous operation is still in progress, and the final value is not yet available. During this time, the promise is essentially waiting for the operation to complete. Once the asynchronous operation completes successfully, the promise transitions to a fulfilled state. This indicates that the value is now available and can be accessed. However, if an error occurs during the asynchronous operation, the promise will transition to a rejected state. This signifies that the operation failed, and an error message or reason is typically provided. To work with the eventual value of a promise, you use the then method. This method allows you to specify a callback function that will be executed when the promise is fulfilled. The callback function receives the resolved value as an argument, allowing you to process the result of the asynchronous operation. Similarly, you can use the catch method to handle errors that occur during the asynchronous operation. This method allows you to specify a callback function that will be executed when the promise is rejected. The callback function receives the error message or reason as an argument, allowing you to handle the error gracefully. By chaining then and catch methods, you can create a sequence of operations that will be executed in order, regardless of whether the promise is fulfilled or rejected. This allows you to handle both successful results and errors in a clean and organized manner. For example, consider the following code snippet that uses the fetch API to make an HTTP request. After initiating the request, we use the then method to handle the response. Inside the then block, we check if the response was successful by examining the response.ok property. If the response was not okay, we throw an error to indicate that something went wrong. If the response was successful, we parse the response body as JSON using the response.jsonWAP method. This method returns another promise that will resolve with the parsed JSON data. We then use another then method to handle the parsed JSON data. Inside this then block, we log the data to the console. Finally, we use the catch method to handle any errors that may have occurred during the request or parsing process. Inside the catch block, we log the error to the console. One of the key benefits of promises is that they make it much easier to coordinate multiple asynchronous tasks. You can use methods like promise.all and promise.race to manage multiple promises concurrently and handle their results in a coordinated manner. By using promises, you can significantly improve the readability and maintainability of your asynchronous code and avoid the complexities and pitfalls of callback hell. They provide a more elegant and structured way to handle asynchronous operations in JavaScript. Async and await make asynchronous code look and feel synchronous, improving readability. An async function always returns a promise. Use await to pause execution until a promise settles. Async function fetch data. Try, const response, =, await fetch, ATPs API example.com data. If !response.ok, throw new error, network response was not okay. Const data =, await response.json. Console log, data received, data. Catch error, console, error, fetch error, error. Fetch data. Async, await keeps code flat and easy to follow, especially with multiple dependent async steps. JavaScript supports object-oriented programming through prototypes, not classical classes. Objects inherit directly from other objects, making the system dynamic and flexible. The class syntax, introduced in ES 2015, is syntactic sugar over prototypes. Class animal, constructor name, this .name =, name, speak, console.log, class dog extends animal, speak, console.log, const =, new dog, Mitzi, d.speak, // logs, Mitzi barks. OOP in JavaScript helps organize code into logical reusable units, crucial for managing complexity. Intermediate developers often struggle with the this keyword, which depends on how a function is called. Passing methods as callbacks can change this, leading to bugs. Use bind or arrow functions to preserve context. Prefer =, over =, to avoid type coercion surprises. With promises, always return a promise in then chains. With async, await, don't forget the await keyword. Attention to these details prevents subtle, hard-to-find bugs. High-quality code is clean, efficient, and maintainable. Use meaningful names, consistent formatting, and modern features like let, const, destructuring, and the spread operator. Avoid blocking the main thread. Use web workers for heavy tasks. Debounce or throttle frequent events to boost performance. Modularize code with ES modules, import and export, to keep files focused and reusable. Embrace the single responsibility principle for easier debugging and scaling. These habits set the foundation for professional, scalable JavaScript. To advance your skills in the world of JavaScript, it's essential to understand that there's no single path. but rather a collection of strategies that, when combined, can lead to true mastery. Think of it as building a house. You need a strong foundation, solid walls, and a reliable roof. Similarly, in JavaScript, you need a firm grasp of the fundamentals, practical experience, and a commitment to continuous learning. Combine theoretical knowledge with hands-on projects. Don't just read about concepts, implement them. Start small, perhaps with a simple to-do list application, and gradually increase the complexity. The more you code, the more you'll internalize the language's nuances and develop a problem-solving mindset. Build applications that use closures. Closures are a fundamental concept in JavaScript, allowing you to create functions that retain access to variables from their surrounding scope, even after the outer function has finished executing. Understanding closures is crucial for writing efficient and maintainable code. Experiment with different use cases to solidify your understanding. And asynchronous code. JavaScript is single-threaded, meaning it can only execute one operation at a time. Asynchronous programming allows you to perform long-running tasks without blocking the main thread, ensuring a smooth user experience. Master promises, async, await, and callbacks to handle asynchronous operations effectively. Learn a modern framework like React. React is a popular JavaScript library for building user interfaces. It allows you to create reusable UI components and manage application state efficiently. Learning React will significantly enhance your ability to build complex and interactive web applications. Or, Vue. Vue.js is another excellent choice for building user interfaces. It's known for its simplicity and ease of use, making it a great option for both beginners and experienced developers. Explore Vue's component-based architecture and reactive data binding to create dynamic and engaging web experiences. To master UI patterns and state management, user interface patterns provide reusable solutions to common design problems, while state management techniques help you manage the data that drives your application. Understanding these concepts is crucial for building scalable and maintainable web applications. Study JavaScript engines. Understanding how JavaScript engines like V8 work under the hood can give you a deeper appreciation for the language's performance characteristics. Learn about compilation, optimization, and garbage collection to write more efficient code. The call stack. The call stack is a data structure that keeps track of the functions that are currently being executed in your program. Understanding the call stack is essential for debugging errors and optimizing performance. And the event loop. The event loop is a mechanism that allows JavaScript to handle asynchronous operations efficiently. Understanding the event loop is crucial for writing responsive and performant web applications. For deeper insight, delving into these core concepts will provide you with a more profound understanding of how JavaScript works, and enable you to write more robust and efficient code. Read books like You Don't Know JS. This series of books provides an in-depth exploration of JavaScript's core concepts, helping you to understand the language at a deeper level. For advanced knowledge, investing in your knowledge through books and other learning resources is a crucial step in your journey to becoming a JavaScript master. Stay curious. Follow blogs. The JavaScript ecosystem is constantly evolving, so it's essential to stay up to date with the latest trends and technologies. Following blogs and online publications is a great way to stay informed. Join communities. Connecting with other developers is a great way to learn from their experiences, share your knowledge, and get help when you're stuck, and contribute to open source. Contributing to open source projects is a fantastic way to gain practical experience, learn from other developers, and give back to the community. Read others' code. Studying the code of experienced developers can provide valuable insights into best practices, design patterns, and problem-solving techniques. To discover new patterns. By analyzing different coding styles and approaches, you can expand your own repertoire and become a more versatile developer. The language evolves. JavaScript is a constantly evolving language with new features and updates being released regularly, so should you. Embrace continuous learning and adapt to the changing landscape of JavaScript to stay ahead of the curve. Mastery is a journey of continuous learning and practice. It requires dedication, perseverance, and a willingness to embrace new challenges. But with the right approach and a commitment to growth, you can achieve your goals and become a true JavaScript master. JavaScript has grown from a simple scripting tool to the backbone of the web. As an intermediate developer, you're learning to write not just working code, but clean, efficient, and maintainable solutions. Each challenge, closures, async flows, builds your fluency. The ecosystem is vast and always changing. Keep exploring and building. Your skills now are the foundation for tomorrow's web apps. Embrace the journey. JavaScript evolves, and so will you. With curiosity and practice, you'll help write the next chapter of the web story.